Some of you are finding difficulty with the open-ended questions in the latent assignment. That doesn't surprise me. As I said at the meet on Wednesday, and I know some of you couldn't manage that, so that's why I'm just sort of recording this to make it a little bit clearer. And you can also rewind this if you wanted to. So the question is, what do all these have in common? So you've got a dog panting there, you've got a shower of curtain of water, somebody sweating, two pop bottles, with one with a wet paper towel on it and a bottle of wine in a porous pot. In each case, there's a change in state. The change of state is from liquid to gas or vaporization, and in each case there's a latent heat of vaporization that's taking heat energy. For instance, with the dog's tongue, the latent heat energy is taken from the blood of the dog to cool the dog down, because dogs don't have sweat glands. With the sweat on your skin, your body releases the liquid of sweat through the sweat pores. The liquid evaporates. The change from liquid to vapor is what takes the latent heat energy from the skin and therefore cools you down. Similar with the bottle there, and the same principle here. So what's happening is there's evaporation. Because the porous pot is not glazed, that means that water actually evaporates from the surface of that, same as it evaporates from here, and in both cases taking that heat energy actually cools the substance down. With the water curtain here, that actually takes heat energy out of the air, making the area underneath this area here much more comfortable in a hot climate. If you need a little bit of help on hot climate, I can go through that as well if you've not travelled much from Inverness. In these cases, this is a freezer block, some ice and a cooler pack. The change of state here is is from solid to liquid. When you change from solid to liquid, again, there's latent heat of fusion is required. And in that case, it takes heat energy, in this case from the food that's in the cool box. In this case, it takes the heat energy from the water in the glass. And in this case, it takes the heat energy from whatever you put that to if you've got an injury. So when you're answering these questions, it's always a good idea to refer to the change of state that's going on, whether it's between solid, liquid or gas, and whether the heat energy is given out or taken in. So here's an example here with the fridge, which was asked about here. In the dotted line, that's the actual body of the fridge. And the changes that we've got going on here is the compressor pushes the refrigerant, which is a gas, and condenses it to a liquid. And as you do that, there's heat energy given out. So if you put your hand around the back of the fridge, you'll actually feel that there's heat being given out. That heat energy is coming from the liquid there now, expanding through this constrictor valve as a gas. And as it goes from liquid to gas, then it has to get some heat energy to do that. And it takes the heat energy, it kind of steals the heat energy from the food, and therefore the food inside the fridge gets colder. That gas then goes through the compressor pump, gets pushed back in, and gets converted back to liquid. And so the whole cycle repeats. Key things, the change of state, gas to liquid, so you're giving the heat energy out there, and liquid to gas, so heat energy is taken in and therefore removed from the food. With this question here, a really good open-ended question, you're supposed to just look at this and go, oh look, there's some water heating, but what's the physics involved there? Again, it's the Bunsen's providing latent heat energy, and it's also providing enough heat energy to get the cold water up to boiling point, and that's specific heat capacity. Any change in temperature, delta T, is specific heat capacity. Any change of state, the boiling of the bubbles, so you can see in the second photo there, if the heat energy is causing boiling, then that's latent heat of vaporization, and so that's what the heat energy is doing there. Okay, some of you also had some really good points about things like the bubbles rising because they're less dense in convection currents, which was good to see you'd remembered from last year. The last one is that somebody's feeling warm, they jump into a heated swimming pool, but they get out and they feel cold. So the reason that that's happening is even though the water may be warm, when you come out, because you've got liquid water on you, a bit like sweat, that one will then evaporate. It takes heat energy from your body. That means that you then cool down, and therefore you get cooled by latent heat of vaporization. So if you want to maybe leave it for a few days and then go back to those questions without playing back the recording like this one bit at a time, but try yourself on those again and then compare your answers to what I've just gone through. It's to see how well you could answer those open-ended. But hope you found that useful, and I won't be generally repeating anything on a Google Meet from now on. You've got to be there, or you'll just have to find out from somebody else what you missed.